What would you think if I told you that warp propulsion is no longer pure science fiction? Can you imagine that we will soon have spaceships traveling at the speed of light or even faster? Scientists have even discovered a completely new way to travel 10 times faster than the speed of light. You'll be amazed at the fantastic changes this will bring in the future. Faster than sound, faster than light. Concorde, the supersonic passenger plane that took just 3.5 hours to fly from Paris to New York, was a milestone in aircraft development. Concorde has long been history. Today, only fighter jets fly at supersonic speeds. We humans have long since reached the next threshold on our way into space. We need spaceships that are faster than light. Otherwise, the enormous distances in the cosmos cannot be bridged, and we would need millennia just to reach the next star system. For a long time, physics did not seem to allow humans or anything else made of matter to travel as fast as light. What was the reason for that? Well, it's simple. Einstein stated in his equations of general and special relativity that nothing in space can travel faster than light. Matter can't travel even close to that speed because, in that case, equations of dynamics and energy requirements no longer applied. Scientists truly had to think hard to solve this puzzle. Now, there may be a way to bend time and space to our will and create a spaceship that can travel faster than light. If you love science fiction space movies, you already know the warp drive. From real life, the spaceship accelerates for a moment. Then, only a bright light can be seen, and matter disappears in time and space to reappear at any place in the cosmos. Enormous distances are covered in a very short time, and travel to the farthest reaches of the cosmos would be real. Although the concept was popularized as pure entertainment by authors such as John W. Campbell and legendary Enterprise creator Gene Roddenberry, science picked up on the concept in the 1990s, bypassing Einstein with a trick. Einstein's theory of special relativity states that energy and mass are interchangeable, and travel at the speed of light is impossible for material objects with a non-zero rest mass. This means that objects traveling at the speed of light require an infinite amount of kinetic energy to reach that speed. The dilemma can be solved by folding or warping space around the object. Warp means to distort or to bend, being thrust with energy. The force is invested in distorting the space. A kind of fold is created through which the spacecraft then slips with relatively little effort. Einstein's theories, which have become the scientific foundations of cosmology and physics, were unaffected by this concept. Two problems remain: generating the energy to fold space and technical feasibility. In 1994, Mexican physicist Miguel Alcubierre solved the problem, at least at the theoretical level. He used Einstein's theory of general relativity during his doctoral studies at the University of Wales to develop a framework within the limits of the laws of physics that would allow faster-than-light travel. On the practical side, relativity states that objects become heavier and heavier as they travel faster and faster. It's logical. The heavier these objects become, the more difficult it becomes to maintain acceleration or even increase it to the point where a spacecraft reaches the speed of light. Only particles that have virtually no mass can travel at these enormous speeds. Photons are among them. Miguel Alcubierre developed a drive named after him. The principle is simple and easy to understand, even for laymen. A purely local expansion of the space-time continuum behind the spacecraft and a contraction in front of it allow motion that is perceived as faster than light by observers outside the distorted region. The occupants in the distortion, on the other hand, would perceive nothing, or let's say, not much. Perhaps they would perceive the famous tail of light, see the stars whizzing by, or notice a slight vibration. Within a few moments, a warp spaceship could cover immense distances, truly as if in flight, or, otherwise said, in faster-than-light flight. The Alcubierre drive is virtually capable of expending an enormous amount of energy to contract and twist the space-time continuum in front of it, creating a bubble that simultaneously folds space. This bubble is a physical inertial system, which is why the occupants would not feel any actual acceleration. However, the rules of physics would be obeyed inside the bubble. Inside and outside, everything would conform, and nevertheless, matter could move in this way, faster than light, through space, only not with thrust and speed as we know it from cars, airplanes, or space probes, but by an ingenious trick. And it is this distortion of the space-time continuum found at all corners of the universe that we experience as gravity. Yes, even you are distorting space-time a little bit right now as you are sitting there in front of your computer or smartphone and you are causing gravity. In this context, of course, the exciting question arises whether a human being could also push through a time fold by consciously contracting the space in front of him and come out somewhere else in space. Theoretically, this is possible. Practically, however, you would have to produce a whole quantity of force in order to distort the space by a multiple more than this happens only by your weight. The Alcubierre drive creates the bubble, which is necessary to evade the laws of physics in the outside-inside with a propellant. This is exactly where we still have a bit of a problem because whether we use diesel, gasoline, hydrogen, or methane, we currently can't muster the power. In fact, we would need energy equivalent to the mass of Jupiter to muster the energy with means known so far. In the meantime, however, a solution has been found for this problem: negative matter. This exotic substance, which has a negative mass or energy density, in theory, is supposed to be the long-sought answer. However, if we look a little more exactly, then we must find that here again, a tiny little problem appears. Negative matter is not only hard to imagine but also undiscovered so far. Its existence is suspected, but it is not proven. So how to construct a drive with something that may not even exist? And even if we could detect this form of matter, the question is, how could we collect or create enough of it to power a spaceship? Where there's a problem, there's a solution. Researchers don't rest easy when it comes to warp drive because we need it. There's no question about it. Before we turn to the latest and most ingenious idea of a practically absolutely feasible warp drive, let's take another look at where we humans stand technically right now. Hold on tight because now it could become painful for all who dream of faster-than-light travel. Our fastest spaceship. Speed of light is a universal physical constant that is approximately 300,000 kilometers per second. The fictional Enterprise could carry its heroes through space and to new adventures at maximum warp speed, 9,000 times faster than the speed of light. Currently, our space probes are the fastest spacecraft we have. Probes are quite small and light. Nevertheless, they also need an immense amount of thrust to reach destinations such as Jupiter, Saturn, or Venus. The Juno probe, which orbited Jupiter from 1995 to 2003, traveled through space at a top speed of 74 kilometers per second, which is just 0.02 times the speed of light. Voyager 1 took nearly 35 years to leave the solar system and is now more than 21 billion kilometers from Earth. The fastest spacecraft ever built by humans is the Parker Solar Probe, which reached up to 191 kilometers per second near the Sun. With these numbers, it's probably already clear to you that we humans do not make it very far with the technologies in the cosmos. For us, even small distances are great challenges. We could say, in cosmic scales, that we can just put our foot in front of the front door. Probes that scientists send into space usually use sophisticated acceleration maneuvers on the gravitational fields of planets to make any progress at all with a reasonable expenditure of energy. Some probes first orbit the Earth twice, then Venus, or they use Jupiter as an acceleration helper. On seemingly endless orbits, they slowly approach their destinations in the solar system over the course of several years. Imagine your buddy from the Proxima Centauri system invites you for coffee, and you would have to fly dozens of circles around some planets with your spaceship to get out of the solar system at all. And with the technologies available to us, probably nobody would arrive in time, not even approximately. Because, as it is at present, you would have to plan more than 100,000 years for a visit to the cosmic neighbor. The fact is, in such a way, we don't advance in the universe. And if we want to someday be a species that conquers space, new technologies must come, a realizable technology. The developments in the area of warp technology go constantly further. Dr. Eric Lent of the University of Gingen recently presented a groundbreaking new approach to warp drive that bypasses the traditional problem of using negative matter and extremely large amounts of energy. In his study, Dr. Lent describes how acceleration to the speed of light could be achieved using physical properties that already exist and can be implemented. The key lies in the use of so-called warp bubbles. This method only requires already known positive energy densities. Nevertheless, this technology still needs quite a bit of research in terms of its technical practicality. While people in Dresden were still thinking about this, the next groundbreaking announcement came. Dr. Harold "Sonny" White, a former NASA specialist, has discovered a real warp bubble. Although Dr. White was already researching the feasibility of a warp drive at NASA, he was actually working on something else entirely, and that was the Casimir cavity, which is observed between two metal plates placed extremely close to each other. Within this cavity exist tiny structures that are natural warp bubbles. The Defense Advanced Research Projects Agency is currently funding further research in this area. We basically just need to somehow mimic these small structures on a large scale and nicely. And the first true warp drive and possibilities for interstellar travel could be available. Become a subscriber now to never miss an incredible video.